Good morning, students. So today we are discussing atoms topic. So in the last class we have completed with dual nature of matter and radiations. So today we are discussing about yes, we are also doing according to the reduced syllabus only, Srivarani. Okay, reduced syllabus only we are discussing. Yes. Okay. So here you can see the first we are discussing about what do you mean by atom. So what do you mean by atom? Already in the chemistry you have studied about the atom is. So what do you mean by atom? How you define the atom? In the chat box you can tell how you can define atom. What are the constituent particles of the atom? So two questions are there for you. What do you mean by atom? Smallest unit of matter, yes. So the smallest part of the matter is called as what? That is called as the atom anta ಹೇಳ್ಬೋದು. Okay. Then what are the constituent particles of the atom? What are the constituent particles of the atom? So atom consists of, that is so okay to see your students. So what do you mean by atom? Atom is nothing but, and all the particles, all the elements consist of very small invisible particles. Those are called as what? Atom anta ಹೇಳ್ತೀವಿ. Or you can take any one matter. So if you consider any one matter, if you break it into small pieces, last line whatever the smallest particle will remain alla, that is called as what? Atom anta ಹೇಳ್ತೀವಿ. So atom is the smallest particle of the atom, smallest particle of the matter. Yes, protons, neutrons, and electron are the components of the atom. So every atom is a sphere of radius of the order of 10 raised to minus 10 meter, in which entire mass is uniformly distributed and negative charged electrons revolve around the nucleus. So here what happens? This is actually conclusion only we are discussing first, because in this chapter we are discussing how this atom model is developed. But before going to that, here we are defining the atom, then we are going to start with the lesson. Just you should have the idea of that world. Okay, yes. So whatever the atom is there, every atom is a sphere of radius. Either the radius ಏನಿರುತ್ತೆ, this is of the order of 10 raised to minus 10 meter ಅಂತ ಹೇಳ್ತಾರೆ. So center of the atom, here whatever the center of the atom is there, the center is the full mass of the body is concentrated at one part, that is called as what? Nucleus. It is called as what? Nucleus. And what we are discussing here, whatever the constituent particles of the atom is there, that is three particles we define. There is protons, neutrons, and the electrons. Okay, so now one by one we will discuss how this theory developed, who named it as nucleus, how they discovered about the atom, that we are going to discuss next. Yes. Okay, so before that, here one experiment I want to share how this atom model is developed, that is Giger Marsden experiment. So see the picture or the experimental figure. Yes, here you can see the experimental figure for the Giger Marsden experiment. Okay, so in this chapter, we start with this experiment itself. So in the figure, what you are observing, that is one radioactive source is there. So what this radioactive source is doing, this radioactive source is giving out the alpha particles. Okay, so from this source, we are getting the alpha particles. So when the alpha particles are coming out from the source, so source andre en madutte, the source is giving you the particles, right? So here the alpha particles, whatever it is coming, this will hit that gold foil. You are able to see in the figure here, you can observe the gold foil. Okay, when these alpha particles will come and hit this one, here the alpha particles, some will get transmitted, so some will get transmitted and some will get, that is deflected. So some will get deflected, some will get transmitted, and some will be absorbed here. Okay, so whatever the deflected particles are there, whatever the deflected particles are there, here one detector they will keep. With the help of the detector, they will just observe it. They will just observe how many particles are there and with what angle it is getting scattered. This is Giger-Marsden experiment. So based on the suggestion of Rutherford. So Giger-Marsden, you might have not heard about the name, but Rutherford you might have heard the name, right? So what this Rutherford will do, based on his suggestions, this experiment was conducted. So okay, so according to this experiment, one source is there. From that source, the alpha particles are coming out. It will hit the gold foil and it will get transmitted, reflected, and some will be absorbed. To observe the deflecting angle, here one detector they are placing. Okay, so what is the experimental conclusion of this experiment? Here, after performing this experiment, here, if they plot the graph between the number of particles of the alpha particle, this is 10 to the power of 7, and here that is angle. So if they plot the graph, this is somewhat like this. Okay. So number of alpha particles is scattered along y-axis. These are the number of alpha particles, and here we have the angle. So what I told you here, with different angle, these are getting deflected. So if you plot the graph between them, the nature of the graph is a curve. Okay. Yes. So what is the observation of this experiment here, students? See, the first observation is, the first point is what? There is most of the alpha particles go along straight line through the gold foil. So illenagatte antandre, most of the alpha particles without getting scattered, they are going the straight path. Okay, so from the source it is coming and it is hitting the gold foil, and after that it is just going in a straight path. So this is the first observation of the experiment. What is the second observation? Here only about 0.14% of the incident particles of incident particles deflected by more than 1 degree. So out of all the 5 particles, most of them are going in a straight path, and only about 0.14% of the incident particles deflected by more than 1 degree. Only, okay, so more than 1 degree, estirate 0.14%. What is the third observation of the experiment? The third observation is about 1 in 8,000 of the incident alpha particles deflected by more than 90 degrees. So here what is happening? 3 observations we can observe in the experiment. The first observation is most of the alpha particles will go without deflection, and only 0.14% of the alpha particles more than 1 degree. Third observation is, that is, third observation is about 1. So 8,000 particles only, incident particles only one, okay, it is deflected by more than 90. So this is the conclusion of the Marsden experiment. So this experiment was conducted based on the suggestion of the Rutherford. Okay. Yes. One of the next experiment regarding this. So after Giger-Marsden experiment, here Rutherford will also give some of the points regarding this experiment. Okay. So what Rutherford will say based on this experiment? According to Rutherford, he argued that, so based on his suggestion they will do, but the conclusion was given by what? Giger Marston. Conclusion yaar kodtare? Giger Marston kodtare. But what this Rutherford will do, he will put some objection for this conclusion. So Elaine Giger Marston in conclusion ಹೇಳಿದ್ರು 3 points ಗೆ. Rutherford what he will put? He will put some argument, objection ಅಂತ ಹೇಳ್ಬೋದು ಇಲ್ಲಿ. So what are the objections to this experiment? So the first one is to deflect the alpha particle backward, it must experience a reflex, that is repulsive force. So now the most of the alpha particles are getting going straight path and some is getting reflected. So reflect whatever the alpha particle is there, alpha particle is having some charge, correct? So whenever any charge is moving, so that charge should return back or it should get attracted to each other. So there must be either attractive force or the repulsive force. In the experiment we are seeing it is getting reflected back. So experimental ಏನು ಹೇಳ್ತಾ ಇದೀವಿ, reflecting back ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. It means that there is some repulsive force and this force could be provided if the greater part of the mass of the atom and its positive charge were concentrated tightly at its center. So what Rutherford will say, that is there is some objection. So the objection is what? The alpha particle is returning back means what? We know that already alpha particle is a positively charged particle. Yes. So when we know that positively charged particle, it is reflecting back from the gold foil anta andre center inda. It means that at the center something is there which is also positive, because you know that according to the properties of the charge, positive charges will return back, right? So when it is returning back, it means that at the center again we have the positive charge. Yes. So here, whatever the center part is there with positive charge, and that center part, the new Rutherford name it as what? Nucleus. Rutherford ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? Nucleus ಅಂತ ನೇಮ್ ಮಾಡ್ತಾರೆ. Thus Rutherford observations or the assumptions could not okay. So here what is happening is at the center we conclude that there is a positively charged mass and this positively charged mass is called as what? Nucleus. Thus Rutherford's assumption could explain the large angle scattering of the alpha particles. Okay. So based on his suggestion, the experiment was conducted. So conclusion was given by Igor Marston. His conclusion, Rutherford will put objection. Why he will put objection? Because alpha particles are returning back means he will not put objection. It is kind of what he will do the argument. Okay, so returning back means what? The positive charges are there at the center. So positive charge ge ಏನಂತ ಹೇಳ್ತೀವಿ, that is called as the nucleus ಅಂತ ನೇಮ್ ಮಾಡ್ತಾರೆ. Okay. ಹಾಗಾದ್ರೆ Rutherford will conduct one model. So according to Rutherford model, here what is the conclusion of the Rutherford model that we can see? Yes. See, Rutherford consists of 4 conclusions. So from the results of these experiment, Rutherford possessed the following model of an atom. So according to yes, just confirm whether it is visible or no. Yes, now you see. Okay, so the screen is visible to everyone. Okay, students, so what are the conclusions of the Rutherford experiment? See the second observation, students. What is the second observation? The nucleus occupies a very small space as compared to the size of the atom. So according to Rutherford, the nucleus occupies very small space as compared to the atom. Okay, so atom ಮತ್ತೆ nucleus compare ಮಾಡಿದ್ರೆ nucleus ಏನ್ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ it is very small. So ನಾವು ಏನ್ ಹೇಳಿದ್ವಿ, atom is only the smallest one. ಅದರಲ್ಲಿ nucleus occupies very small space as compared to the size of the atom. ಅಂದ್ರೆ atom size ದೊಡ್ಡದಿರುತ್ತೆ compared to the nucleus size. Go for the third point. The atom is surrounded by a suitable number of electrons so that their total negative charge is equal to the total positive charge on the nucleus, and the atom as a whole is electrically neutral. See, what is the third point? So here what they are saying, as you know that the atom consists of the three particles like protons, neutrons and the electron. So what they are saying, atom, so iದೇನ್ atom ಇದೆ ಇದು ಯಾವ ರೀತಿಯಾಗಿ behave ಮಾಡುತ್ತೆ, it behaves like electrically neutral. Electrically it behaves as neutral. So why it is behaving as neutral? Because in number of positive charge irutte, same number of negative charges will be there. Okay, so therefore here the number of positive charges and the number of negative charges are same here. Therefore what we can say, when they are same, the atom is electrically neutral. So see the last point, the electrons revolve around the nucleus in various orbit just as planets revolve around the sun. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ ಅಂತಂದ್ರೆ electrons are revolving in a circular path around the nucleus. Okay, so it is comparably with the the planets revolving around the sun. Yes, go through all the 4 points. If any doubt is there, please ask. Yes, any doubt is there in the 5 points? Third point. Okay, see what is this third point is saying, that is the atom is surrounded by the number of electrons. So how many number of electrons will be there? So in short what we want to say is atom will behave as neutral particle. So if it wants to behave like a neutral particle, so hope so you know what you mean by the neutral particle. See, in the atom, if the number of positive charges are more, if the positive charges are more, then it is said to be what, positively charged particle or the positively charged atom. If negative number, I means electrons are more, it is said to be negatively charged particle or the atom. So here in general, if you want to call it as neutral, it must be positive number of electrons, sorry, positive number of charges must be equal to the negative charges, right? So that is protons and the electrons must be equal in number. Then you can say that they are neutral. It is neutral. Okay, the atom is neutral. So that is the third point. See, is it clear? Okay. So here we said that the last point, what it is saying, that is the electrons are revolving in a circular path. So circular path, you know that what is the forces acting in the circular path? That is nothing but the centripetal force. Okay. So here we can equate the centripetal force with the electrical force. So the centripetal force is given by what? mv square by r, and the electrical force is nothing but the Coulomb force. So what is Coulomb forces formula? That is K into Q1 into Q2 divided by R square. So once you equate this, whatever the unknown values are there, you can find out this. So later to calculate the radius and velocity, this formula is useful. Just remember this concept. Okay. Going for the next point, students. If any doubt is there till now, you can ask. So we have discussed about the alpha ray scattering experiment, Giger-Marston experiment, and the Rutherford experiment, and the conclusion of the Rutherford experiment. Okay. What are the drawbacks of the Rutherford experiment that we will discuss now? Okay. So why Rutherford model will fail? See the drawbacks. This model could not explain instability of the atom because according to classical electromagnetic theory, the electron revolving around nucleus must continuously radiate energy in the form of electromagnetic radiation. So the Rutherford model, it will not explain that. What is the meaning of this statement here, students? That is, as we are saying that the electrons are continuously revolving in the around the nucleus, right? So when it is continuously revolving, it will, so it requires some energy for that. So from where this energy is coming, and if it is moving, the energy loss will takes place. So if the energy loss is taking place, then why it is able to revolve around the nucleus continuously? So here the question arises. Therefore the Rutherford model will fail. Okay. So Rutherford model, why it will fail, this you need to remember for the 1 mark. Yes. See here one definition, that is distance of closest approach. So this definition they will ask for 1 mark. So what is the distance of closest approach? Let us discuss. So when an alpha particle of mass m and its velocity is v moves directly towards a nucleus of atomic number z. So here what all they are giving the quantities, that is the velocity is v, mass is m, and the charge is, atomic number is z. So if the alpha particle is moving, initially its energy is taken as E, which is just the kinetic energy. And the energy is nothing but here the kinetic energy. Okay, this kinetic energy completely converts into a potential energy. Whatever the kinetic energy is there, that is getting completely converted into the potential energy at the stopping point. This stopping point happens to be at a distance of closest approach d from the nucleus. So what is distance of closest approach? Here what happens, whatever the kinetic energy is there when the electrons are moving here, at some point when it is approaching to the nucleus, at some point here the kinetic energy of this particle becomes zero. Or you can say that the kinetic energy is getting completely converted in the form of what? Potential energy. So from the center of the nucleus at yav point ali idagutte, what is that? That is kinetic energy is becoming zero. That distance is taken as what? Distance of closest approach. It is denoted by small d. Okay, so what is distance of approach here, students? It is nothing but the kinetic energy is completely getting converted in the form of what? Potential energy. Or you can also say that from the center of the nucleus where the kinetic energy is becoming zero, that distance from the nucleus to that point is called as what? Distance of closest approach. Okay, so distance of closest approach, suppose if they are asking you to calculate here, what you need to do is just equate both the energies, that is the kinetic energy and the potential energy. But potential energy you are not going to take it as mgh. Okay, so this is not the potential energy because this is gravitational potential energy. Gravitational potential energy illenu use illa. We have to go for electrical potential energy. Getting my point? Okay, so what you need to do is, suppose if they're asking you to calculate the distance, mass, or anything related to the distance of closest approach, you need to equate the kinetic energy equation with the electrostatic potential energy. So what is electrostatic potential energy, students? In the second topic you have studied, that is 1 upon 4 pi epsilon naught ZE into 2E divided by R. Okay, so this is the electrostatic potential energy. So 1 upon 4 pi epsilon naught ZE, that is for the nucleus, 2E, that is for the alpha particle, divided by R, or you can also write it as what? R naught. So take down this formula here. I think all the terms you know. Just you remember, ZE is for the nucleus. ZE is for the nucleus. And ಯಾವ atomic ಬಂದಲ್ಲಿ approach ಆಗ್ತಾ ಇದೆ. And whatever you are writing 2E, this is for the charge of the alpha particle. So 2 times of the charge of the electron. Yes. So actually the potential energy, gravitational, the electrostatic potential energy is given by what? 1 upon 4 pi epsilon naught Q1 into Q2 divided by R. So here one Q1 is for the nucleus and one more Q2 is what? That is for the alpha particle. Okay. So accordingly we are taking the formula. Yes. So note down this point. One derivation we will do, students, that is the expression for the radius of the atom. Okay, so we will do one derivation, one small derivation we will see. So just you remember regarding the distance of closest approach, for 1 mark they will ask this point. Yes. So the derivation is, that is expression for the radius of the nth orbit. So here we are doing the expression for radius of nth orbit. Okay, so to derive the derivation, already I told you, that is here in the atom we are equating the two forces. We are equating the two forces, that is, one is the centripetal force, as it is moving in the circular path. The centripetal force we need to equate it with the electrostatic force. So what is the electrostatic force? It is 1 upon 4 pi epsilon naught. So it is ZE into E divided by R square. So what is ZE here, students? That is for the nucleus, E is for the charge of the electron. Okay, so Z is for the, remember the terms, m is mass, v is the velocity, r is the distance. So 1 upon 4 pi epsilon naught is constant. Z is for the nucleus, E is for the charge of the electron, and r is for again the distance. So here what we can do, that is If we rearrange this term, here we will get it as Z square upon 4 pi epsilon naught. Okay. Next we are getting it as what? That is mv square divided by. So here 1 r will get cancelled. We are left with what? That is mv square r. So mv square r is equal to Z square upon 4 pi epsilon naught. Make it as equation 1. Yes, any doubt is there in these two steps? Here you know one more point, that is we know that according to Bohr's atomic model, that is mvr is equal to angular momentum is equal to nh upon 2 pi. Do you remember this one? Bohr's atomic model. Yes, according to Bohr's postulates, we say that mvr, that is angular momentum, is equal to the integral multiple of h upon 2 pi. So we are using this one in the equation 1. Okay, so what is equation 1? Equation 1 is mv square r is equal to z square upon 4 pi epsilon naught. And according to Bohr's postulate, we have mv r is equal to nh upon 2 pi. So let us substitute this now. Make it as equation 2. So we have equation 1, equation 2. So we are squaring this one first. So equation 1, so equation 2, square it. Squaring this equation, it becomes m square v square r square is equal to n square h square upon 4 pi square. Yes. So first squaring the equation. So after squaring this equation, divide equation 3 by 1. So dividing equation 3 by 1. So if you divide equation 3 by 1, what we are getting? See, this is equation 3 is what? It is m square v square r square divided by m v square into r, which is equal to. So equation 3 first ಬರ್ಕೊಳ್ಳಿ, it is n square h square upon 4 pi square into. So equation 1 is what? It is 4 pi epsilon naught. Reverse agate because it is in the denominator. So I am taking it in the numerator, therefore I'll just reverse it. And this is z square. So 4 pi will get cancelled, but 1 pi is remaining here. And here m you can cancel. V square values you can cancel. And 1 r will get cancelled here. So what is remaining here, students? So in the numerator, here we have m, here we have r, which is equal to, here it is n square h square epsilon naught divided by z e square into pi. So see if any other terms will remain or any other term will add when you are dividing equation 3 by 1. Just check it. Yes, correct. Simplification is right. So we require only the radius. Therefore, if you transfer that m, what we are getting there, the radius r is equal to, so we require it for the nth orbit. Therefore, Rn is equal to, it is n square h square epsilon naught divided by, so here m is in the numerator, therefore here it will come to the denominator, m z square into pi. Okay, so this is the radius of the nth orbit. So see the derivation. If any doubt is there, please ask. So this will come for 3 mark. Okay, any terms or any of the steps. So first what we did, we have equated the electrostatic force with the centripetal force. Equate it, and after that use the Bohr's postulate. So according to Bohr's postulate, that is angular momentum is equal to n into integral multiple of h upon 2 pi. Then after that, the second equation we are squaring it. After squaring, divide 3 by 1. And lastly, we are getting Rn is equal to n square h square epsilon naught m z square into pi. Copy down this. If any doubt is there in any of the step or any term, if you don't know, please ask. Completed, students?